This is one of my favorite questions from Nest 21 Shift 1 question 1. Suppose f is a differentiable function on closed interval 0 to 1 such that the derivative of f is continuous on closed interval ab. Let f of 1 be 6 and f of 0 be 1. Then the limit as n tends to infinity 1 upon n summation k goes from 1 to n f of k by n into f dash of k by n is 35 by 2, 25 by 2, 5 and 0. Now this question makes use of definite integral as limit of a sum for sure, correct? For sure it makes use of definite integral as limit of a sum. But secondly, it also makes use of substitution method. Okay, it also makes use of substitution method. If you don't follow it, what we will do is, let us assume that g of x is f of x into f dash of x. Okay, and now this move is encouraged from the sum end here. Okay, f of a k by n into f dash of k by n. Now let's take into consideration this. N tends to infinity 1 upon n summation as r goes from 1 to n g of r by n. Well, I use r because that is a more convenient notation and we have been using r in our theory. So everyone agrees with this? This will be integral 0 to 1 g of x dx. Please raise your hands if you understand it. And if you don't understand it, please ask me. I'll explain it once again.
So how you assume f x and f dash x is g of x, right?
I didn't assume it, I put it. There's no need to assume anything there. Got it? See, what was our original definition? Limit as n tends to infinity b minus a by n summation r goes from 1 to n f of a plus rh, right? Or r into b minus a by n. And that becomes integral a to b f of x dx. The change that we have brought in is only notational, so we have used g instead of f because f is already utilized for some other purpose in the problem. Clearly a is equal to 0, a is equal to 0 and b is equal to 1. So a0 and b1 means b minus a is 1, a is 0, so that will be f of r by n on this side and it's 1 upon n. Got it? Which means now you want it to be 0 to 1 f of x into f dash of x. Why? Again invoke the change that we brought in, right? This is actually g. F of x into f dash of x is actually g, isn't it? Now put f of x as t. F dash of x dx would be dt. If you put f of x as t, f dash of x dx should be dt. And what will happen to the limits? Ready, limits are ready here. Okay, so if we prepare our usual table, 0 to 1, if if x is 0, t will be 1. If x is 1, t will be 6, right? So we'll have t going from 1 to 6. F of x is t, f dash of x dx is dt, t squared by 2, lower limit 1, upper limit 6, 36 by 2 minus 1 upon 2, 35. Option A. Okay, so I hope you understood it. So very nice combination of limit of a sum and substitution method. Who knows, they might give you by parts also. Did you get it?
Yes, sir.
So I think this is pretty much IISc aptitude test level problem. Not too difficult, not too easy. Requires you to know the basics and then you eventually get the limit. ठीक है.